Welcome. My name is Joe Staller with Epic Resins, and I'm here with Erika from Electric Goddess. And she's going to share some of the details of the great services and engineering abilities that Electric Goddess can provide for designing and engineering batteries and battery packs. So welcome. Thanks for coming.
Thanks for having me.
Yeah, so I guess one of the first, burning questions I have is, when engineers are having an issue or they're coming to you, what are the main reasons that they're coming to Electric Goddess?
Thank you for the question.
Yeah.
Electric Goddess provides research and development services, and so that's very broad. Sure. And I like to separate it into two different categories, right? There's battery teams that are coming to us reactively, meaning there's some sort of problem and they need some way out. They might have spent 6 months, 1 year already on that, and then they're like, we need some serious help, or they've known us for a while and they're like, this is a question for Luke and Erika.
Awesome.
And then there's also the proactive teams. So these are new teams that maybe want to build out their battery expertise, would like to bring in some bigger experts or more knowledgeable in battery people,
sure,
and then provide that knowledge to their team to help them grow. And that's personally my favorite because It's like the cheapest, the fastest. It's how to do a battery right.
Of course.
And it's great to work with new people, excited, hungry people that want to learn about batteries. And what we would provide is basically helping them through testing, understanding their test plan. How are they selecting a cell? What are they actually building? Like, what does success look like?
Of course.
So that's step one. And then just helping them, like, what's the fastest way to get what they want done?
So I'm kind of curious, so between those reactive versus proactive, I guess, how does that business, is it pretty much 50-50, or are there more, I'm hoping more proactive versus reactive, or what is the split of the business, can I ask?
Maybe with our clients, because we're very lucky in what we've taken on, is probably proactive. But through the 7 years of working on Electric Goddess so far, I actually really was kind of taken aback by how hard it is to be proactive in the battery industry. Everyone wants to do it their own way. Everyone wants to figure out basically how do they make the best without bringing in outside consultancy. So proactive, I feel like, is very more difficult. So I almost took a sort of motherly approach where I'm just like,
sure,
wow, okay, so if it's difficult for me to help them at the beginning where it's the easiest,
sure,
and the cheapest, then how can I be there for the end? And that's actually where Luke will talk about the battery recycling company that we joined and started.
Sure.
And I was like, if we can't be there at the beginning, then unfortunately we need to be there at the end and
take
help
care of those problems that they have. Absolutely.
Yeah, and I know that's kind of a backwards way to think about the battery industry, but truly with the knowledge and the people and the expertise working on these batteries, there's great battery systems out there, but also there's a lot of not so great battery systems that are being sold as great battery systems, and it's really hard to know the difference without an expert eye.
Are you finding that those folks that are more proactive are also more successful?
I would say in our client base, I mean, we have Fortune 100 companies. They have bigger budgets, but it's more controlled. They have more success driven, right? They're not just like trying to get a prototype and like make their next funding round, which is kind of like where the startups come in. I would say that they are very successful because they're very methodical, and they maybe have the decades or 100 years behind their whole organization that know that to bring in expertise.
Awesome. You had to break it down into 3 or 4 tests.
Sure.
That are the big tests that almost every engineer wants you guys to run.
Sure. I would say that we kind of start at the selection of materials and then go from there.
Okay.
So it would be like cell selection first. So we run a lot of electrical tests, and then also the thermal of the performance of those cells is super important.
Awesome.
And safety of those is important. So when we get a new cell, or maybe we'll get a bracket of 5 or 10 different types of cells. We'll run some regular electrical baseline tests. We'll even abuse them. We'll go into the safety test. We'll understand the energy release of them.
Awesome.
And then also, once we choose one, then you can dive really deep into like thermal simulations and starting to understand your battery pack design. So from there, we would take those cells that we selected, start looking at adhesives, other interface materials, and make smaller designs of what this battery concept would be. And then we'd run more tests on them. We really focus on failure tests, and that's because we've been bitten by standards. I think they're great. They need to be there. We need to pass them. But also you need to understand what's your margin to failure. And that's really where we focus on in design. So on those small scale tests, we'll run those. And then from there, we can start building for production.
So you talked about your guys testing batteries to failure.
Right.
How can a customer avoid failure by designing their parts properly with Electric Goddess's help?
We've seen a lot of things fail.
Sure.
We're not perfect, of course, but we also chase down every rabbit hole to a benefit and a fault even. Like we really like to see the mechanisms of everything. And we provide our clients with like, this is the failure mode, we've recreated it. And these are the possible mitigation strategies.
So coming to Electric Goddess early is a good way to avoid having future problems potentially.
Yeah, I have a great template on how we can run different battery programs. Throughout my career, I've done over 50 battery designs. Luke has millions of batteries out there in the industry working from space, aerospace, energy storage systems, data centers, buses, cars, scooters, motorcycles.
Sure.
Like really seeing a true wide range of battery applications and what it takes to make something rugged for those.
So to make things rugged, why is it important to test a failure to make something rugged?
I can tell you from a high level perspective.
Let's hear it.
And it's just to know the failure margin. Because if you have a standard, for example, and your standard says you need to put your battery 1 meter underwater and hold it there for, let's say, 24 hours.
Sure.
That tells you, does your battery last 24 hours in regular water? And that's it. That's a check mark, right? So what happens if I'll never forget this story about a motorcyclist who was riding on the beach and the tide came in and the motorcycle was just left on the beach because the tide took the motorcycle and he went back the next day to pull it out of the surf and then goes back to his garage and plugs it in trying to charge. Like those are real examples of how people are using batteries. It could happen to your phone, like laptops, anything. And so you want to know, like, customers are going to be more creative than you could ever think. And what is your failure margin as a company? Because you're going to get that call whether or not you hit the standard.
Explain to me what you mean by failure margin.
Well, cells inherently hold energy. And energy can be released. And what you don't want is all of your cells within your battery pack to chain release all of those energy at once. That's where you see the news reports of batteries running away, thermal runaway. And so what I really like to do is if there is a cell defect, and of course we help companies implement quality control when they're in production to reduce the probability of a bad cell getting into a pack. But let's say it does. You don't want that cell to cause chain reaction. So we test to failure of like, what is that worst case scenario, right? Let's say we embed, let's say, a fiber laser into a cell and actually simulate what it would be for a foil edge short within a cell and protect against propagation to other cells. So we design for that worst case, like what keeps you up at night as a battery engineer? It's like a cell making it into a battery pack, right?
So you help engineers sleep at night?
I would say so, yeah.
Awesome, that's great.
That's my goal. I like to sleep. I sleep very well.
In your experience, what have you found the challenge when potting material is actually chose last? The case is all designed and then they finally say, okay, well now we're gonna pot this. What do you see the challenges that customers have when that happens?
I think there are some engineers that actually just really hate potting, to be very blunt about it. Sure. And I've actually seen some teams handle that, some management teams handle that by letting parallel designs happen.
Sure.
Right? Like, let's just test this out and let's do one without potting, do one with potting. What I've seen specifically, if eventually 99.9% of the time I've seen that you do go to potting if you want to build a rugged design for life on Earth.
Sure.
What I've seen is that it puts people in a very tough spot because you might already have your tooling done.
Sure.
You might have already bought a bunch of parts. And so going into like adding extra weight to your battery to give the protection that the battery needs, that puts management in a very tough position on, do you do that versus not? It passes the standards. Do you ship it as is?
So solving that problem is starting
ways.
from the beginning. It sounds like solving those problems for engineering is starting with potting in mind from the beginning as opposed to later in the process.
Absolutely. Yeah. And if you have teams that push back on that, just run the data. Like make your sample packs and get the test data, and that'll tell you exactly if you need it or not.
Awesome.
It's very important to test early and design early with potting. I've seen this save millions of dollars. I've seen this save years of time. And it truly is a path to the win in batteries.
Awesome. Thank you for that. Appreciate it. Thank you everyone for joining us with our discussion with Erika at Electric Goddess. Thanks for joining.